So for our next example, you're going to need your calculator. You can pause the video if you need to get that out. And so on this problem, we're solving our trig equation. We've already got our trig function isolated. So cosine theta is negative 0.9. That's not on our unit circle, which is why we need our calculator. And so let's first rewrite this, taking the inverse of both sides. So we have that inverse notation. All right, so on your calculator, make sure that you are in radian mode. Okay, so I am, then you can hit second quit once you're sure. All right, so we're going to hit second cosine and then negative 0.9. All right, so our principal value is 2.69. It continues. You can just write to the nearest hundredth. And what we're going to do is we're going to store that value because we're going to need it later. So go ahead, if you've forgotten, you're going to hit stow right down here. Hit stow. And then we need to pick something to store it as. I like to pick the x, t, theta, n button if at all possible. If I'm only going to store one value, I pick that one because it's just one button. I don't have to deal with alpha or anything like that. So make sure you hit enter. Okay, now that value you can see is stored as x. So we're going to use that value to write our general solution equations. This is a cosine curve, so we're using our cosine general solution equations from the pink sheet. And so we're going to write our principal value, 2.69 plus 2 pi n, and the opposite of our principal value, so negative 2.69 plus 2 pi n. Okay, great. So then we're going to plug in different n values here, and n, remember, is an integer. So it could be 0, 1, 2, 3, and so on, or negative 1, negative 2, negative 3. Always an integer value. And so when n is 0, we're not adding anything to either one of these. All right. So when n is 0, we've got 2.69 and negative 2.69. And for me, it's easiest to just stick with one of my two equations and add and subtract 2 pi n. So we need to know when to stop, right? So our particular solutions need to come from 0 to 2 pi again. It won't always be the case, but when we're getting started, it will be. Okay, so we're looking to stop when we get to 2 pi, so let's think about that decimal approximation. Just in case you've forgotten, you can do 2 times 3.14 or just 2 times pi. Kind of have that in the back of your mind. So I like to think about that one. All right. So I know I'm going to stop once I get values at 6.28 or higher. Okay, so then I also want to kind of think about, does this make sense? If I'm starting at a positive value and I'm adding 2 pi, I'm going to use the pi button, I should get a value that's bigger than 2 pi itself. All right, so let's just double check. So we're going to say our 2.69 plus 2 pi times 1, so just plus 2 pi. Okay, so here's x, that's my 2.69, plus 2 pi. Yep, it's bigger than 6.28. So I know I'm not going to include that in my set. All right, now let's take a look at when n is negative 1. So 2.69 plus 2 pi times negative 1. All right, okay, so I'm going to say x minus 2 pi. You could also say x plus negative 2 pi. That would be fine too. Okay, so then we get this negative 3.59 value. All right, but remember, we're looking for values between 0 and 2 pi. So already we've got two values we don't even need. We're going to get rid of the negative. We're going to get rid of the value that's bigger than our 6.28, our 2 pi. So anything outside of that domain, we're going to exclude. Okay, so from this equation, we have exactly one particular solution. Now let's look to see if we have any more particular solutions. So for starters, we've got a negative when n is 0. So I'm not even going to bother looking for anything less than that because it's already outside of the domain. So I'm going to get rid of both of those. So then what I'm going to do is I'm going to look for negative 2.69 plus 2 pi n. I'm going to go to the calculator. So now I'm going to do negative x plus 2 pi. Okay, so I'm adding when n is 1, so just plus 2 pi. Okay, there's a value that's less than 6.28. So that's viable. We're going to keep that. And just in case, if you wanted to double check, let's see what happens if we add another 2 pi. If you add another 2 pi, that's basically saying x plus 2 pi times 2. So I'm just going to say plus 2 pi. It's faster for me. And it's in line with what I'm doing when I'm not using the calculator. Okay, so you can see you get 9.8, way bigger than 6. Get rid of that. All right, so we now have exactly two particular solutions between 0 and 2 pi. So that's our theta. Okay, so then remember your general solutions are the equations. So we do have both, and you'll always want to make sure that you're paying attention and you're recording both as your answers. Okay, so we've got our general solutions and our particular solutions.